Hi, welcome to my channel, and in this video we are going to solve MIT Integration B problem 2024. You have this definite integration problem where you have a function inverse cosine, and in the argument you have sine of x, and you are integrating it from 0 to 2 pi. We're gonna do it two way. One way is the easy way using graphical method, and the other one is the long way. That might be the natural way people might attack this problem. So let's see how can we solve this problem. So if you have done inverse trigonometric function, you should have come across this relation where you have an inverse cosine, and in the argument you have a cosine of x, and that is equal to x when x is between 0 and pi, and is minus x when it's between 0 and 2 pi. But our function, we are given instead of cosine of x, in the argument we have a sine of x. But so how can we do that problem? And we know we can manipulate integration functions. If we have this function sine of x, we can write sine of x as cosine pi by 2 minus x. So how can we use this manipulation into for our advantage? So basically what we're gonna do, we're gonna substitute pi by 2 minus x in place of x at all the places. Make sure you change x by pi by 2 minus x in the relation at all places, especially in the limit, because your limits are gonna change. So now my relation become this function. So this is the new relation with pi by 2 minus x. So this relation is basically is pi by 2 minus x when pi by 2 minus x is between 0 and pi, and is the negative of pi by 2 minus x when is between pi and 2 pi. But what we're integrating is x, so we need to find the limit of x rather than pi by 2 minus x. Basically need to change the limits, which is the easy way. And when you change the limit, and you will see it will be a pi by 2 minus x when x is between negative pi by 2 to pi by 2, and it's negative of pi by 2 minus x when it's between negative 3 pi over 2 negative pi by 2. Now we have simplified our function that we need to integrate. We know the limit, and this is just a linear function, and now we can integrate. I'm not gonna do the integration because you can do it. This is just a linear function and you can do integration by yourself, and you will see this integration will come out to be pi square. But this is the very long way. I don't think so. If you are in a competition, you would go into such a long calculation. There's another easy way, and let's see how can we solve problem using an easy way. If you have this function, now this is the inverse of a cosine, and in the argument you have cosine of x. So if you have done the relation that we talked about earlier, you can easily draw the graph, and the graph will come out like this, and you should remember this graph if you are doing inverse trigonometry. So now if I look through a graphical point of view, the definite integration basically means calculating area under the curve, but this is not the curve we are integrating. In the problem we have sine of x in the argument instead of cosine of x, but we already seen we can change our sine of x into cosine of x by saying sine of x is equal to cosine of x pi by 2 minus x. What this pi by 2 minus x is basically doing translation, and if I translated my graph by some amount, my area is not changing. So what I can do is basically calculate the area under my this graph instead of shifting it, because I'm gonna get the same area. If you know, you're gonna calculate the area under this graph, which is basically this is the triangle. How to calculate the area of a triangle? You have half base time height. In this case the base is 2 pi and the height is pi, and you see you get the same answer of pi square. So I'm making a lot of math, science, computer science video. So if you wanna learn about all those things, make sure to subscribe, like and share. Less